Okay, so these are toe clamps. These are half 13 TPI kit. The way this is supposed to work is these clamps, whatever's in line with it in any direction needs to be the same clamp. And it all needs to be centered. You'll notice the slot has the same disposition as the other one does. It's not all the way up here, it's not all the way in the back, and this one's not all the way up in the front, so on and so forth. These sets come with different sizes. What the set looks like is that. So everybody gets the same set. All of these rods are always the same size. So when you get these, the nuts aren't specific, the rods aren't specific, the clamps aren't specific. The only reason this clamp is bigger and taller than this one, or thicker than this one, is because this clamp has to reach further, so it's got more concavity stress to it. Another thing to notice, these little triangles come in different sizes too. There's a large one, there's a mid-size, and there's a small one. There are wrong ways to set this up. You'll notice that this one is set up wrong because it does not engage all the teeth. This one is set up correct. This one engages all the teeth. And then this one is correct because this one engages all the teeth or more. What you do not want to do is have one that does not engage all the teeth, because at that point, by design, it is not set up correctly. If this moves in that direction, this will tip over. This is another way to set them up. Flat surface. This is an allowable way to do it. Another thing to notice too is you notice that these threads are not fully engaged. This one is engaged. This one is engaged. So these nuts are wrong. These should be tightened down more, which means this rod that is threaded into this table needs to come up as long as it's fully engaged on the bottom, which it is, and this needs to get threaded further onto it or get a taller rod. Another thing to notice, these are all flat. None of these are sitting like this or like this when they're clamped down and in their position. That's how it needs to be. When you tighten these, there's not a torque spec. That is just an answer to a problem that never should have happened. The way these work is you get them fit, nothing's moving, put a wrench on it, that's tight. There is no torque spec. Putting a torque spec on these is actually by design not correct. Nobody in CNC does it, nobody in valves does it, nobody in other industries do it, because these are not specific. The moment arm, meaning the pivot point, if this slides back, this torque spec goes away and goes to a different torque spec. If it slides forward, it's a different torque spec. Up here, it's a different torque spec. Up here, it's a different torque. So it's entirely too many procedures to make for one job. Essentially what you would do is the setup would take 3 days and the test would take 20 minutes. It's not correct. It's a knee-jerk reaction to a very easy situation. The way you can define which one of these broke first is, let's say this one breaks first. If this one breaks first, this side is going to lift. When it lifts, these are not going to hold. What they're going to do is they're going to turn. And this nose is going to work its way off this side. This thing's going to pull out and it's going to lift. Whichever one of these lets go first or turns on center is the way it's going to let out. So whatever side, if this one breaks, it'll have almost no markings on the actual valve flange. If this one's opposite of the one that broke, there will be all kinds of gouging in the flange of that valve. So you'll know which one held on the hardest, because what it's going to do is it's going to turn it up and it's going to gouge all over inside of here. So you'll know that this one's the one that broke. The way the markings are, you're going to find scraped up paint on the bottom of these toe clamps that'll tell you where they were when the thing was clamped down. Because this one's going to have a whole bunch of paint on it. This one's going to have a straight gouge on the actual valve flange, this one's going to have like an arc from turning away from it, and this one's going to have nothing because this one just let go. So there's not going to be any marks on the side that actually broke. Now, when I looked at one of these was broken off here, and there was bluing. Bluing is the color you see here. This black is not what the steel is from the factory. This is a dye that they put on it. If you look at it close enough, you can see that the metal is kind of porous. It's kind of spongy on top. What they do is they get this really, really hot, then they dump it in oil, and then what happens is it gets spongy on the outside. That makes it porous. It can receive liquids. So they put this stuff called cold blue on it, and when you put that cold blue on it, it soaks into those pores while it's still hot, and it makes the surface resistant. So when you bang on it with things, the outside surface doesn't scratch or dent. The bluing actually makes the metal harder. It's the same way when you see like different colors of aluminum. That is an anodizing. That makes the aluminum harder. Next thing is the dye penetrant test for how this is supposed to be set up. Alright, so this is the dye penetrant set. We're going to test it on here to see if there's a crack. We know there's a crack, we can see the offset. But, for the sake of this video, I'm going to show you how we test to see if that crack's there, if it was a lot smaller than what we could see. So this is the cleaner. You spray this on first, wipe it off. This gets out oils. This is the penetrant. You spray it on, let it dry for a second. This is the developer. This will make the red bleed. Doesn't matter how small of a crack it is, even if it's in cast, which these are cast steel. So, you take this, spray it on. We get it nice and clean before we perform the test. This is not a test you would do on the current situation because, well, it's already broke. We know it's cracked. Then, you'll take this, and you'll spray that on. Alright, so now it's been dried for about 5 minutes, and I wiped everything off. You don't use any cleaner for it, you just wipe it off. And I use the developer on it, and this is going to tell us if there's any cracks. It's kind of hard to see, but if you look at that line, even though I wiped it off, you'll see there's a pink line right there. That's how you know that right in here, there's a separation. That separation would not show anything there, because if you look up here, there's nothing. There's nothing in this area. But you notice there's a pink line right there. That's the break. So, if this were to be the same device as this right here, and this broke, just like the one in the shop did, right here, what you would find is when you take it apart, because this bluing is the last process that they use, this bluing should never be inside of the device. So, if I take this apart, what you'll find is look how far the red got in there. So what ends up happening is when this thing was clamped in, we'll say it was like this, and it broke, and then we look at the brake edge, and we find that there's a big chunk in there that's all blue everywhere, like right up in there, We know that when they got done heat treating this at the factory, what they did was they had a crack in there because the cast was wrong or the heat treating process was wrong, and that bluing made it in there because it was broke when we bought it. However, in order to do this, or to make sure this doesn't happen again, this right here is already in the shops. I use it for weld testing and everything else that I can think of. This needs to be part of the QC inspection. We don't need a process for all of this, maybe a work stop and a stand down to talk about it. We don't need paperwork for this. What we need is, why is this stuff not checked at a certain frequency? Like every year, or M&TE needs to come in here and look at this kind of stuff because it's on a test stand, and they need to do a dye penetrant test on these, make sure they're still good. And that is how you resolve this issue.